So, today, as usual, the lesson can be confusing if you don't pay full attention to it. So, first off, two things are going to be important. The first thing is you need to write everything that I do. Second thing is get at least two colors. Once you've done that, come back and then we'll finish. We're going to deal with something called CPCTC. It's just an acronym that means corresponding parts of congruent triangles are congruent. That's a whole bunch of words. So as usual, I'm going to help you by breaking it down, and we're going to have our own little definition up here at the top. So for CPCTC, what that basically means is, first off, you have to start with two triangles that are the same, or two triangles that are congruent. So I'm going to write if two triangles are congruent, and when I say congruent, you should think the same, then all corresponding parts of the triangles are the same. So when I say that, I mean like angle 1 is going to be congruent to angle 1. So the angle with one tick mark is the same as the other angle with one tick mark. Or the angle in between side 1 and side 2 is the same as the other angle and the other triangle in between side 1 and side 2. Another example would be like if angle 2 were to be congruent to angle 2. Or if side 1 was congruent to side 1. And then these can go on. Down here, we've already covered these. These are just theorems that help us whenever we're trying to do proofs or solve or see if two triangles are actually congruent to each other. The first one is CPCTC. So congruent parts in congruent triangles are congruent. So we can see that obviously here, so let's say this is angle 2 because it has two tick marks. This matches here. So angle, that was that, C, angle C here matches with angle F because these are both angle 2. That means angle 2 is congruent to angle 2. Likewise, here, side 2 would be congruent to side 2. Angle 1 would be congruent to angle 1, and so on. The perpendicular bisector and angle bisector just means whenever we have the word bisector, so bisector, that means we split in half. And half, of course, means two equal parts. And that's the first page done. Now that we've kind of defined what CPTCT is, besides a whole big mouthful of words, let's actually use it in an example. So here, this is what you're going to be given, some kind of question like this. And I'm not just going to throw you into it. I'm going to give you a two-step process that you're going to follow. So I want you to write, first off, how do we use this? Well, step 1 is we're going to find if two triangles actually are congruent. And we do that by our 5 methods. So our 4 main ones are side, angle, side, 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 angle, side, angle, and angle, angle, side. And we also have that weird one that we can sometimes use with right triangles called hypotenuse leg. Well, step one, if we have congruent triangles, then step two is if the triangles are congruent, then we can make a relation between any two corresponding parts. And when I say corresponding, I mean like the same name, like angle 1 or angle 2, or like here, this angle G is between side 1 and side 2, and this angle H is also between side 1 and side 2. So angle G and H, these two would actually be corresponding parts. And that actually becomes kind of important in this example that we're about to do. So this says, prove that angle G is congruent to angle H. Well, hey, if we can prove that these two triangles are congruent to each other, then angle G and angle H are in the same position. They're corresponding. So if these triangles are congruent, then these are corresponding parts in the triangles, and corresponding parts in congruent triangles are congruent. So again, this is a bit of a review of proofs. We're given half of all the stuff that we need. We're given some reasons, some statements, and we got to fill in the blanks. So here, a given. Well, we're not given any statement. This says prove. Like, prove is not a statement. It'll say given something. Well, we are given a picture here, and we're given that this side GF is the same as this side HF, because they both have one tick mark. They're both side 1. So we can say that side GF is congruent to side HF because that was given in the picture here. They're both side 1. Well, similarly, we can look at side 2, this side and this side. Well, this is side GI, and this is side HI. And how you name your sides and your angles is very important, because saying GI is not necessarily the same as saying IG, because GI is starting at G and going to I. IG is starting at I and going to G. Well, when we're talking about corresponding parts, it matters which place we start, because not everything corresponds to each other. So like this angle G right here, this is the angle in the middle of side 1 and side 2. Well, I is not in the middle of those two. So when we say GI, we're starting at the angle in the middle of them and going to the angle that's outside of them. So when we name this side, we have to start with the angle in the middle of the two sides, H, and go to the angle that's outside of it. So here we would say side GI is congruent to side HI. That's also given by the picture. Now, this one is a bit interesting because this is the exact same thing. FI is congruent to FI. Well, we've seen something like that before. If anything is congruent to itself, that's a property. That's called reflexive property. Let's look at Fi. Fi is this one right here. Well, yeah, that's true that Fi is equal to itself, but how does that help us? Well, Fi is in this triangle on the left, but Fi is also in this triangle on the right. So this side Fi is actually in both triangles. So when we say this side is congruent to itself, we're actually saying now we have side 1 going to side 2 going to side 3, and the other triangle side 1 into side 2 into side 3. The pattern matches, so we can prove that the two triangles are the same by side, side, side. Now going back up here, for step 1 was find if the two triangles are congruent. They are congruent, they're congruent by side, side, side. So we're good to go. Step 2, if the two triangles are congruent, then we can make a relation between any two corresponding parts, or parts with the same name. So like side 1, angle 1, angle 2, and so on here. Well, we want to prove that angle G is the same as angle H. With your second color, I want you to put a little arc here and one here. We know these two angles are the same because these two triangles are the same and corresponding parts are going to be the same. And we don't have an angle named yet, so I'm going to name this angle 1 because it's the first angle that we have. So because this is angle 1 and this is angle 1, these are going to be the exact same. So therefore, angle G is congruent to angle H by corresponding parts of congruent triangles are congruent. Now we're going to go down to this one. Ooh, it looks a little bit harder, but it's not really. Just as a refresher, I want to remind you that bisect means to split in half, and half means equally. So here, this says ray VB bisects angle EVO. That's one of the things that we're given here. So we're given this right here. Well, if we're given that, then we just put in given. It's as easy as that. Well, let's look at angle EVO. Angle EVO starts at E, and then it goes to V, and then it goes to O. So it is this whole big thing right here. Well, if we cut it in half, it's made up of what two angles? Angle 3 and angle 4 fully make up angle EVO. So if we split EVO in half, then angle 3 is going to be the same as angle 4 because we split them in half in two equal parts. So we write angle 3 is congruent to angle 4. And that is by the definition of an angle bisector, because if we split it in half, then they're going to be equal. The next reason that we're given is given. We've already used given. Let's go back up and see if we have anything else. It says ray VB bisects EVO and EBO. Well, we didn't use this EBO part, so let's use that here. So we're going to say EBO will go here. So if we have that VB bisects angle EBO, then what does that mean? Well, let's look at EBO. EBO is right here. It's this whole angle right there. It's made up of angle 1 and angle 2. Well, if we split angle 1 and angle 2 in half equally, then we just have angle 1 equaling angle 2. That's exactly what we're given here for this statement. Now, when we did this up here, we gave the statement and they gave us the reason. We're just flipping it here. They're giving us the statement. We have to give the reason. So what was the reason up here? Oh, it was definition of angle bisector. Okay. So now we're going to put in definition of angle bisector. And now again, we have something equaling itself. Like BV is congruent to BV. Well, let's look at where BV is. All right. BV is right there. It's a side that's shared by both triangles. And equaling itself always, no matter what, means reflexive. So now here, I'm going to write in the information that we've gotten up to this point. We've got, now I'm going to do it in a different color to look all fancy. We've got angle 3 matching with angle 4. That was the first thing we did, so I'm going to make that angle 1. Then we went down here and said angle 1 matches angle 2. All right, that was the second piece of information we had, so I'm going to put this in 2 lines. So angle 1 matches angle 2. And then we had a piece of information that BV is congruent to BV. All right, well, I'm going to put that here because that's a side, but that's our first side that we've actually covered here. So it's going to be side 1. So here we have an angle, specifically angle 1, going to side 1, because that's the only piece of information that we're given that's right next to angle 1. And from side 1, we're going to angle 2. That gives us our pattern. Can we go from angle 1 to side 1 to angle 2 on the other triangle? Well, let's look at it. If we start at angle 1, can we go to side 1? Yeah, it's right next to it. It's touching it. Can we go from side 1 to angle 2? Yeah, it's right here. It's touching side 1. So therefore, since we can go from angle 1 to side 1 to angle 2 on both of them, that is angle, side, angle. And we can prove that these two triangles are the same by angle, side, angle. Oh, no, I flipped that around. That's exactly what we have here for the reason. So that means that triangle BEV is congruent to triangle BOV by angle, side, angle. Now, if we go up to the top, did we prove what it asks us to do? It said prove angle E is congruent to angle O. It said prove this angle is the same as this angle. Is that what we've done so far? No. So we need to do that. Well, we know the two triangles are congruent, and these are in the same spot. Like they would be angle 3, because we've already used up angle 1, angle 2, angle 1, angle 2. So E would be in angle 3's position. O would be in angle 3's position. Well, we know they're congruent triangles, and these are corresponding parts of congruent triangles. So, building off of that, corresponding parts of congruent triangles are congruent. All right, now we have a real-world application question. Here, I know it looks super ugly on your paper if you got it printed in black and white. I think all of them are printed in black and white. So what I want you to do is redraw it. I'm going to guide you with how to draw this picture. Super easy to draw. First off, draw a straight line up and down. And then draw a line going diagonally through it. And then connect the two lines. And now to make sure our information is the same as the picture, we're going to have a right angle here in the bottom right of the bottom triangle, and a right angle here in the top left of the top triangle. And then this side and this side are congruent, and then our points are M, N, P, L, and K. Well, right now we've got two right triangles. We have this right triangle and we have this right triangle. There is a method called hypotenuse leg that can only be used for right triangles. So let's try that. Hypotenuse would be the longest side, which is this side right here. It'd be LM and it would be PM. Well, we're not given the sides. I don't think there's any way to find that. We're not given that LP is bisected by M. That's not one of our pieces of information here. We're given that M is the midpoint of NK, that M splits this in half, but we're not given any information about LP. All right, hypotenuse leg won't work then. So let's see what else we can do. So if 90 degrees doesn't have any bearing on the fact that it's a right triangle, let's just treat it as a regular angle. Here, we have angle going to a side, and then if it were to go to a side, that's wrong for two reasons. One, it's not a valid proof of congruent triangles. Also, it spells a bad word, which we're not going to do. So going to a side after here is forbidden. So that means we have to go from angle to side to angle. So that means with your second color, we want this angle to match this angle. Well, actually, those kind of look like vertical angles. And vertical angles are always congruent. So we can say vertical angles are congruent. Remember, whenever you have like a little X shape here, these two angles and these two angles are always the same. So now we do have an angle and then a side and then an angle here, and then an angle and then a side and then an angle. Well, let's see if they match. We go from the right angle to side 1 to angle 1. And then we go from the right angle to side 1 to angle 1. Okay, they match. So now we just have to fill in that information here. Using the given information and vertical angles, We know that triangle, MKL, and MNP. You can name the triangles however you want as long as you do it consistently. But I'm going to say triangle MKL is congruent to triangle MNP by SAS, side angle side. Therefore, and this part is not super intuitive, but if you go back up to our steps, step 1 is to find if the two triangles are congruent. We found it. Yes, they're congruent by SAS. Step 2 is if the triangles are congruent, then we can make a relation between any two corresponding parts by CPCTC. So let's go back here. What's it asking us to find? It says find the distance across the river from point N to point P. So it says it wants us to find NP. Well, N starts at the right angle and goes to the point furthest away from the dot here. So then if we look on the other triangle, we'd have to start at the right angle, starting at K and going furthest away, so it would be L. So therefore, side NP is congruent to side KL by CPCTC. So to find this measure over the river, you would just have to measure what this is on land, and then it should be the exact same distance. Here, we're going to not really deal a whole lot with theorem 6.2, but we are going to look at theorem 6.1. So how can we use our triangle congruence theorems to prove the perpendicular bisector theorem? Oh my goodness, that is a whole bunch of words. Well, let's just start the proof and see what we can fill in. It is given that something. So let's go back to up here at 6.1 and see what we're given. If line CP is the perpendicular, the symbol means perpendicular, bisector of AB. Oh, well, hey, we're given that line CP is the perpendicular bisector of line segment AB. And then here it says it's given that something is the perpendicular bisector of something. So we just fill in this information. Right here, ooh, right here, oh my goodness. Right here, we put this information into that. So it is given that line CP is the perpendicular bisector of line segment AB. You could also look at the picture and tell that because these two pieces could only be the same length and this right angle be here if line CP was the perpendicular bisector. And then it says if this is the case, then we're trying to prove that CA is equal to CB. Or at the very end of this, they flipped it and said AC is equal to BC, but they're talking about the same lines. So because it's given that line CP is the perpendicular bisector of AB, we can use the information from the picture to show that this line segment is the same as this line segment. So line segment AP is congruent to line segment BP. And we're also going to show that this right angle here is the same as whatever the other angle over here would be, which would also be a right angle. Because if this intersects at a right angle on the right side, it's also going to be a right angle on the left side. Now there's a few ways we can prove that. One is just the fact that it is a perpendicular bisector. The other one is this is a straight angle. We've already used up 90 degrees, so the remaining part would have to be 90 degrees. Either way, this is going to be angle CPB and then CPA. So those two angles are the same. So angle CPA is congruent to angle CPB. If we go back and look at our proof, it says by the reflexive property. Reflexive means something always equals itself. And reflexive is typically used when two triangles share a side. So right here, well, the only shared side would be CP. So I'm going to try that. By the reflexive property, side CP is congruent to side CP. And then right here, we have a set of sides that match. We have a set of angles that match. And then we have a set of sides that match in that order because the AP is here, so side, and then CPA is angle, and then CP is here. So side, angle, side, and then on the flip side, angle, side. So by side, angle, side, or by SAS, the two triangles are congruent. Well, did they ask us to solve for the triangles being congruent? No, they said, is CA equal to CB? So we can use Kapakatika to say that since these triangles are congruent, well, these pieces are going to be congruent. So side AC is going to be congruent to side BC. And then if side AC is congruent to side BC, then AC equals BC. And then going on to your next page, this is actually a duplicate of what we just did. So you can mark this all the way off. Unless you want to do it again, which I don't really want to, so you don't have to. Here, we're going to find the indicated measures. Oh my goodness, this looks like something completely different that we've never done before. But we have, you just may not know that we have. Here, this is a congruent side. So we have a side, and then this is an implied 90-degree angle for the same reason as before. If this is 90 degrees, then this has to be 90 degrees. So we have side, then we have angle, and then this side in the middle, like right here, that can be proven by reflexivity. So SQ will equal itself, SQ. So since the second side matches, then we have side, angle, and then finally side for this triangle, and then side, angle, side for this triangle. So they are congruent by side, angle, side. So therefore, we can set any corresponding parts equal to each other. Okay, let's look at SR. SR is what it wants us to solve for. So SR is right here. It's the hypotenuse. Do we have the hypotenuse of the other triangle? Well, yeah, it's right here. It's SP. So side length SR is congruent to side length SP. So that means SR equals just whatever that length is, 6.8. Moving down, it wants us to find EG for this problem. Okay, first off, do these match? Yes, but it's kind of weird how they do. Again, we've got two triangles that meet at the same side, this right here. So this FH is going to be the same as FH. That means we have one side that matches. Well, if you look, this is a right triangle, which means this is a right triangle here. So I'm going to go ahead and I'm going to draw in that box for right triangle. Well, let's try our fancy method that only works with right triangles. If we use hypotenuse leg, do we have a matching hypotenuse? Yes. A matching hypotenuse here and a matching hypotenuse here. Do we have a matching leg? Yes. This right here, HF, is our matching leg. So we do have hypotenuse leg. So we can just stop right there and say, yep, hypotenuse leg, those triangles are the same. We can stop right there for proving the triangles are the same, but have we solved the actual problem? Did we find EG? Well, no, EG is actually this whole length. Oh my goodness. EG is made up of two parts. It's made up of EF, this left-hand part here, and FG. So EF plus FG. Well, if we know that these two triangles are congruent, then EF equals FG. So that means that EG is going to be equal to 9.5 plus 9.5, which is equal to 19? So then EG equals 19. That's what the question asked us to solve. That's what we solved for. Now we're good. The last one for this page, find AD. Okay. This one's kind of easy. It's kind of exactly what we've done already so far. So we know if we see a right angle, we can mirror that over here. So now we have side angle. And then this side right here, BD, well, I mean, that's a reflexive, so that equals itself. So then we have side angle, side, side angle, side. So these match each other by side angle, side. Well, if they match each other by side angle, side, we can set the corresponding parts equal. Let's look at AD. AD is right here. It's the hypotenuse of the triangle. Well, let's find the other hypotenuse of the triangle. It's right here. It's CD. So that means CD is congruent to AD. And then substituting in the values, we have 3x plus 14 is equal to 5x. All right, well, I want to get x by itself and everything that's not x by itself. So let's subtract 2x from both sides to get 14 is equal to 5x. Nope, I lied. 14 is equal to 2x if we subtract 3x from both sides. And then we divide by 2 and get that 7 is equal to x, or to rewrite it, x equals 7. And if you circle that, you get the question completely wrong because it asked for AD. AD is not x. AD is 5x. So 5 times x is equal to 5 times 7, which equals 35. And if you circle that, you get the question right. Good job. Last page, we're going to find these indicated measures. Okay. First off, identify what the problem's asking you to find. It says find angle GFH. G starts at G, then goes to F, and then goes to H. So it wants you to find this whole angle right here. Well, first off, let's see if these triangles are even congruent. Because if they're not congruent, then we can just say they're not congruent, and then we stop there. Well, the longest side of them is this side right here in the middle. That's the one that's shared by both triangles. Well, if JF is equal to itself, then we say by the reflexive property that this side is equal to this side. The hypotenuse matches for both these triangles. They're both right triangles. And then we also have this other side, 7, just a random other leg that matches. So we do have a proof by hypotenuse leg that these two triangles are the same. We've got the angle GFH is this whole thing, but what two angles is it made up out of? Well, it's made out of this one and this one. Angle GFH is congruent to angle GFJ, which is the top half, plus angle HFJ. Now we know these two pieces are going to be the same as each other because these are congruent triangles. So I'm going to, with a different color, just mark in that this is the same, like that. So then we can fill in this. So we have 42 degrees plus 42 degrees, which is going to equal 84 degrees. And if you circle that, you're right. Last one, we want to find SR. All right, SR is this one right here. Starts at S and goes to R. Well, right now we're given a right angle. So let's see if hypotenuse leg works. The hypotenuse is shared. Okay. The hypotenuse matches on both triangles, and SQ is equal to SQ always. So we can actually say that this one in the middle matches itself by reflexivity. However, we don't have another side that matches. We don't know yet if 5x equals 6x minus 5. We can assume that, but then it doesn't really help us if we just say, all right, these are equal, therefore they're equal. That doesn't really help us. We would have to be given the information that this side matches this side. We're not, so we cannot use hypotenuse leg. However, 90 degrees is still just an angle. So if we have angle, angle, side, is that a valid way? Yes. So we're going to say by angle, angle, side, these two triangles are congruent. Well, since these two triangles are congruent, corresponding parts of congruent triangles are congruent. That CPTCT. No, wait, CPCTC. So because that's the case, then SP, or side SP, is congruent to side SR. And if that's the case, we can set them equal to each other. So side SP is 5x. And then we have 5x is equal to 6x minus 5. All right. If we were to subtract 6x from both sides, and there's a bunch of ways to do this, I'm going to subtract 6x from both sides. We have negative x equals negative 5. And then we don't want negative x, we want positive x. So we have to divide out negative 1 to get that x equals 5. And then circle that, and you are wrong if you circle that, because the question didn't ask for x, it asked for SR. SR is 6x minus 5. So if we plug in 6 times 5 minus 5 to this, 6 times 5 is 30 minus 5. That would equal 25. And if you circle that, you're right.